Paul's already summarised pretty much of what we're trying to get through here, which is, I guess, a look at what we're doing, what some of the thinking is around reinforcing, why some of the changes have occurred, and how it's used. Now, I'm not sure, looking around, I can recognise a few engineers out in the audience, but I guess we've got a pretty broad range. So I can promise we tried not to make this too engineering, but there'll be one or two terms in there, and feel free to ask questions around that later on if you need to. So a summary of what we're going to talk about. First of all, just a little bit of discussion around the rebuild, what's happening, what sort of things will be going on. Talking about reinforcing steel, what its properties are, what the different types of reinforcing are out there, and some of the details around that, how it's used in fact, and then focusing more particularly on, in turn, residential and then commercial. So first up, the rebuild. Some of the important stuff in there, you can't really look forward too much without making sure you've looked backwards and just find out what worked and what didn't, and that was quite an important point. And so just a very, very broad summary up here. Most buildings performed pretty well, most modern buildings, with a few exceptions, and you know what some of those are already. Most importantly, the most modern of modern buildings, which were the ones designed since '95, and I'm using the context of reinforced concrete structures here, they certainly went pretty well. Irregular structures, and when we say irregular, we mean buildings which have got very strange floor shapes or different floor-to-floor heights, basically just anything which is not regular, exactly as I said, are the buildings which are more heavily affected, and so we saw more damage to those, as we would have expected. And masonry buildings, of course, the old unreinforced masonry buildings were essentially destroyed. However, the good news is you can strengthen them, and so the strengthened ones did okay. We'll come back to some more about some of that later to show you some of the things that we mean by that. The residential, well, there's a few issues coming up, some of which we've already seen happening, and so since sort of starting this series, going back a year, we were predicting some of the things that might be happening. Now we're sort of seeing some of those things coming through, which is of interest. With some of the issues there, obviously the availability of land has been a pretty big factor out in the media. We've seen that. The valuations of what people are getting paid are based on something which is now a few years out of date, but unfortunately people are having to buy land at current valuation, and so that has an impact on what's going on in the rebuild. Insurance, well, we've seen that going backwards and forwards. I'm not even addressing the matters about getting payouts, but even just looking at insurance coming up, who can get insurance for new structures, for building, all those things is having a bit of an impact on the way people are thinking. And even today they're talking about changes to the insurance policies going forward. And so obviously that flows down into matters I've addressed there, like sale of properties, in the sense of who's been able to buy buildings, houses at least, where you've got damaged houses being traded with who knows exactly what's going to happen with the repairs. And so there's a certain amount of uncertainty over that. And finally, at the bottom, which is really what this, the picture you see there is, what are the standards which are going to be used for the repairs and the rebuild? How do we make sure that what is done to a standard that we can live with going forward, so we don't get this sort of thing happening again? Many of you will have seen this map. Obviously Christchurch is now a map with many different colours on it. We used to think of there being really just one type of soil under the city, but in point of fact there's many. And so you can see in there quite clearly, if this is working, you've got the red zone through there, but we've now got the all the blue, yellow and grey, which you hear people talk about, the TC1, 2 and 3, and everything that goes with that. What do those things mean? Well, if you're on TC1, as anyone knows, that's good news. Not likely to have liquefaction in the future, therefore no change. Carry on as you did, apart from the one major change, which is you must put ductile mesh in slabs, and we'll come back to the reasons for that in a minute. TC2, you've got some chance of liquefaction, and basically the new standards are there. You can use 3604 that we're familiar with just a few modifications to make it work a little bit better, depending on the type of structure you've got. And finally, TC3, which is the stuff which is not so good, liquefaction is likely, and that's all going to require specific design. So there won't be anything standard about the way that we deal with TC3 land going forward in the sense that we've been used to it. Commercial buildings, there's some interesting things there. So prior to the earthquake, there was around about 400,000 square metres of commercial office space in the city, of which about 275,000 was in fact occupied. So in other words, we had quite a lot of empty space even before the earthquake. So, and it came at costs which were fairly well understood at the time, so about $300, probably to $350 a square metre was what you used to have to pay for Class A office space. and around about 220 to 250 was Class B. Now, we've got, of course, since the earthquake, a lot of people have moved out of the CBD, but there are those who are thinking about coming back in, and what does it mean to them? And so there's a lot of question mark about, A, how much commercial office space will be required in the city going forward. Lots of people have moved out to some of the business parks, and they might be quite comfortable out there, even though it's a little harder to do business that way. And on the other hand, lots of people anticipating how much it's going to cost, because you'll have seen stuff in the paper about how much it's going to cost to rent space in the city. People are saying around about $450 a square metre, so that's $100 a square metre more than it used to be. What impact is that going to have on the market? And I think when we were looking at this, we were saying, well, the current estimate at that stage was about 180,000 square metres of space. In point of fact, I think they're saying initially it's going to be a lot less than that. So it's going to take a little while for that rebuild to gain momentum because of the lack of demand, or the changes in demand moving forward. And so that's the sort of thing that Hare are having to grapple with. You've seen, many of you, obviously, what's going on with the planning changes. And so we had the nice, the meeting down here in the event centre where people talked about what they wanted in their new city. I think they based that on a function in Melbourne where they got 1,000 people to give suggestions. Over here we got over 100,000 suggestions. And so, as you can imagine, from a city's point of view, trying to turn that into a single cohesive document has been a bit of a challenge. But, and there's a lot of things in there. It's affecting height limits, it's affecting some of the land use considerations going forward. So all of that has an impact on the rebuild. The city map I won't spend too much time on because you've probably mostly seen that, but obviously we've got the around here, the Avon River, and then the frame, which is work which has started off already, some of the planning around that. And then you've got the major facilities in there, which is going to follow along. So the convention centre, the hospital precinct, and the hospital itself for that matter. You've got the justice centre and all the other major facilities. And so those have become the anchors around which, I guess, they're looking for the rest of commercial development to take place. And once again, sort of there's a little bit of wait and see going on. I think people want to see what's happening with those major anchor projects before there's a full commitment to what goes next. But it's all starting to happen now. You've seen the temporary facilities. You're all from Christchurch, so we don't need to talk about that very often. I'm sure everyone's been along to the container mall, which has been more of a success than I think I would have expected it to be, but I think it's been a great initiative to get people back in the city, remind them it's there and get them involved. New building design. Some of that's going to be affected by code changes. A lot of it's going to be affected by owners' expectations. And so we've had a few different reactions to that. I can think of a particular building where the developer came along and said, make it like a hospital in Wellington. And to which our response was, I don't think you really know what that means. That's quite a lot. That's probably a lot more than you need to do. And so eventually we agreed to compromise, which was we'd design it as if it was a hospital in Christchurch. But even that, so that means we add a lot of strength that we wouldn't have added. But strength is not always the issue. And so some of the way the ways that engineers have to be asked to respond and some of the things that owners are expecting, there's some interesting mismatches. It's quite a challenge for engineers to be able to talk with the owners and the developers as to what's really going to be the most effective thing to suit their particular situation. Building code updates, obviously there's going to be some. We've seen the Royal Commission has popped out with a number of recommendations, some of which will impact on the building code. But as we might know if we think backwards, it takes a long time for building code revisions to flow through. So what do we do in the meantime? There's been a lot of building evaluation and repair go on. It's been a lot in the news, not just in Christchurch for that matter. People have been looking at buildings all over the country. In Christchurch, that's basically for all non-residential structures, there's got to be this evaluation happening. At this stage, that's still work in progress. There's been about 2,000 submitted. This was as of a couple of months ago actually, so there's more since then. And about 1,000 of those evaluations have been agreed and approved and passed on. So that's building momentum, but it's an important part of the recovery. It's not just enough to have new structures. We need to have confidence in the ones we've got, that we know that they've been repaired properly, and to know that we have to know that the damage has been identified properly. And then, obviously, in the short term, the damaged structures, getting the stability concerns addressed. Picture there for those who haven't seen it. I think that's one of the hotels down Manchester Street. So we've got the old facade being held up by containers. I won't spend too much on this, but the detailed engineering evaluation procedure, that's the thing you've heard about. That was something developed by the Engineering Advisory Group, which is assisting what was the Department of Building Housing, now MB. And it's a process of inspection and review of structures. And so it's more about from the engineering perspective, it's less about establishing how strong the building is. It's more about establishing that we've understood actually what happened to the building. I won't go on too long about that, but the reality is that a lot of the time you'll hear a building has X% MBS, as everyone refers to it. I'd say those numbers are not nearly as important as the fact that someone's taken the time to look at a building and understand how it behaves. There's actually relatively little link between percent MBS and whether the building's likely to fail in an earthquake or not, surprisingly. For those that are interested, you can download it from CSOC. The Royal Commission, hopefully none of you had the pleasure of spending too much time in the courtroom. It was a pretty intensive process for those that did, and some of you might remember. It has published 7 volumes of report now. It's complete. And somewhere in those reports there are 189 recommendations of things that need to be done. And some of them are fairly simple things, and some of them are going to take a long time to actually get to the bottom of. And so there's a lot of people working on that now, largely MB, the Minister of Business, Innovation and Employment, has been set the task of dealing to a lot of those things. And that's a work in progress, which won't happen overnight, but it will eventually happen, we hope. I tried to pull out whatever the implications were for reinforcement, since I need to come back to the topic at some point. And so there were a number of things there which had some implications for reinforcement. And I'll come back in more detail. So discussion about research into a sequence of loading, yield penetration, lots of good engineering terms, but these are quite critical as to how buildings will behave in the future. And more recently, some of you may have seen there was a consultation document out about earthquake-prone building. Identification, how we fix them, how we should go about doing that. And so that goes back to that dilemma I was talking about a minute ago, where do we worry about the capacity of buildings in the way that it has been reported, or do we think of another measure which actually tells us what's dangerous and what's not? Capacity is not the issue. We know there's a lot of buildings which are under strength, but do we really know which ones are going to collapse? Because that's what we're most afraid of. And the answer is a lot of good work has been done in the background on that. Just to give you a bit of an example of that, guess some scores. Here's a building which was evaluated post-earthquake, and someone said it was worth 9% MBS. Now, as I've said plenty of times, I would be quite happy to go and live in that building, from a stability perspective at least. On the other hand, this one was evaluated at 67%. So it's just to illustrate very quickly how it is that capacity, which is calculated, is not necessarily the answer. There are other factors which come into that, which engineers have to be on top of. So where does all that go? Well, obviously the codes and standards, even changes to the Building Act, are going to follow. Even with the most optimistic view, I think we'd say it's going to be 3-4 years before we see major code changes coming through. There'll be some short-term interim updates, but that's about all. In the short term, CSOC has put out some what we call interim design guidance, which is available for engineers to be able to pick up on some of the lessons we've learned in the quicker sense. They might be a bit conservative. In fact, we've deliberately aimed for them to be a little conservative, but with a view of making sure that in 5 years' time we're not going to look back at what we're building now and say, well, we wish we'd done something a little differently, because those things have all changed now. And so we've built buildings in the last 5 years which will, as we'll be going forward, which will be not as good as we wish they could have been. So, conclusions about the earthquake. Well, obviously it's provided us with a lot of lessons, especially about concrete structures, and a lot of that unfortunately tells us mostly that we need to do a lot more research. Some of them behaved exactly as we wish they would have, others didn't. And so can we identify which ones have gone well and learn from them as well as the ones which have gone badly? We need to think a bit harder about how we manage our older building stock, because there's a lot of problems out there, and we've got lots of buildings all up and down the country which need consideration. So Christchurch has had its earthquake. We could arguably say we're going to be the safest city in the country because all of our bad buildings will have been weeded out. But what about the rest of the country? We need to get on with it. Earthquake-prone buildings have been an issue for as long as I can remember. So I think the first piece of legislation around that was 1968. So I pointed out to someone not that long ago that I'll have been able to have an entire career in the time it's taken these city councils to actually address these problems and not even solve them yet. And so we need to think about actually doing something this time for all those places where we still have earthquake-prone buildings. We've got to look at what goes on with the neighbouring buildings. How many buildings did we see in the earthquake which were closed after the earthquake, not because there was something with that building which was wrong, but because the neighbouring building was going to potentially fall on top of it? And in point of fact, that was quite an important factor in some of the injuries and deaths we had in the earthquake, was exactly that problem. And finally, well, not finally, there's a lot of other hazards we need to think about as well. So what about rockfall? Those of you who've seen pictures of what happened to some of the houses up in the Port Hills would have been, as I was, pretty concerned about it, what the impact is of rocks as big as a tank coming down the hill towards you at a great speed. And that's going to take a lot of training. So it's training of engineers and other members of the building professions, but it's also training of the public, what to expect. We would have saved 8 lives, I think it was, if we had enough people, everyone knowing, for example, not to run out of their buildings in an earthquake. And so how do we get all those messages across? So it's great that we get people along to these sorts of events. We need to get that more widespread. So getting back onto topic now, reinforcing steel, what do we do? We know about a lot of the things we put reinforcing into concrete for. We put it in there to resist bending, to resist shear forces, for axial loads, a whole variety of reasons. And those are all good reasons. And we can design to those things pretty well. We know what some of those effects are. We've got codes and standards to deal with that. It's important we get it right, but we know those things. However, there are a couple of other things that we don't sort of think about which are not in the building code. So stretch and offset are a couple of terms I'll use to describe them. And that's particularly important for those of you who are dealing in the residential space. What's stretch? Well, picture, if you will, a house, which normally they'll look a little better than that, and think what happens when we get the earthquake. We get ground movement, and if we've got liquefiable soils, or if we're close to a watercourse, we can get lateral movement. The impact of that is the house will pull apart. And so we've seen plenty of places after the earthquake where we had houses which were pulled apart by the ground, not because they weren't designed properly, they were designed to the code, but the code didn't tell us that those sorts of things were happening. And that's the thing about codes. You've got to think beyond what's in the code sometimes. And so gradually, with more and more shaking, those buildings were pulled apart. So what could we have done about that? Stretch and offset. Well, for a kick-off, put some reinforcing in the slabs. So a lot of those houses which had that problem didn't even have reinforcing in them. What we need to add to those buildings is ductility. And so ductility basically means that a building is going to be able to hold together. It's going to be able to resist loads above and beyond what you necessarily designed it for. So I've got up there very much the engineering definition of ductility. And to most people, and probably even a few engineers, that's not necessarily going to mean a hell of a lot. And so we talk about that in respect of the elongation which reinforcing bars can go through. Good ductile steel, such as what we're talking about, can stretch and it will yield, but it will continue to stretch and stretch and stretch. And so that's what this next diagram is showing. If you've got ductile steel, it might, and this is what we call the load versus displacement for those things. And so it will stretch gradually until it hits a certain point, which we call its yield stress, and then it will tend to taper off, but it will continue to go for quite a long way. So in other words, it doesn't just snap at that point, it bends. So if you think of the difference between bending a piece of wood, which will just snap, or bending a paper clip, which will continue to bend, it's exactly that. You'll hear engineers talking about capacity design, and capacity design is a pretty simple concept, even though they managed to dress it up. And all it amounts to is basically identifying the weak link in a chain and then making sure that that weak link, so in this case the one right in the middle, is ductile so that it continues to deform, and it basically, by being the weakest link and by continuing to deform, it prevents all the other links in the chain from being overstressed. So in other words, we can have, if we must, brittle elements back here down the chain, but because that one there is yielding, it doesn't, those ones will never be overstressed. Now back in the old days, we used to use what we call cold-drawn hard wire mesh, the old 665 and 663 that we used to pop into our topping slab. So this is a picture of what happens to that in an earthquake. And as you can see up there, I hope you can see better than me, you'll see a bar there which is fractured, a piece of that mesh, because with a relatively small amount of stress put into it by the earthquake, the movement, it's got to its limit and snapped, and therefore, when needed, wasn't able to do its job. If that had been ductile, that wouldn't necessarily have happened. In general, but not always, we find that the lower strength steels, and 300 MPa by the way is a typical grade, are a little less ductile. But they all have a certain amount of ductility, which is the length of this, reflecting the length of the curve as opposed to that first bit. On the other hand, and unfortunately these are not all drawn at the same scale, you'll find that whereas you've got a typical mild steel pattern up there, which is a bit of yield and then the elongation, you'll find that a cold drawn wire will come up and snap. Now these things look like they're getting to the same point, but that point there, if that scale was normalised to be the same as the other ones, would actually be way back here. So in other words, they fly up and they snap, and that's that. Now those are the meshes we need to be avoiding. That's what we used to use, and we shouldn't. To put that onto one picture to illustrate that better, here's a piece of reinforcing proper mild steel, and here's what happens with that bar. So in other words, at very, very low strains, it'll just break. And so we've got to be on the lookout for that. We mustn't be putting that into new buildings. Another reason for that is because in an earthquake, as we know, you don't just get one movement, you get a lot of movements. And so the buildings go backwards and forwards many cycles of loading. And so what we can see here is a bar, a history of a bar which has been stressed, then dropped back, and then stressed and dropped back. And so what we see is the bar gradually, as it gets taken through greater strain, loses its ability to go further. And so once again, if you've got those brittle bars, the non-ductile steel, it can't take multiple cycles of loading, which is what we need to be able to do. Some of you may or may not see this one. 4671 is the reinforcement standard we work with. So that sets out what these reinforcing steels have to achieve. There's a whole lot of different grades, and remember this is a document which is used in Australia as well, where they don't necessarily worry about earthquakes so much. But there are two grades which we should be using, 300E and 500E. So that's E for earthquake. And that's all we should be accepting, generally speaking, in structures in New Zealand. What that means, once again, you can see that, if you're looking for it, that some of those numbers which we were talking about over here, the elongation, when you go down to the bottom end, you're talking about 1.5% or 5% elongation, 15% for grade 300. And so we're looking for much greater amounts of ductility in that steel than what we get from stuff if we use the wrong steel. The designations of that, I won't spend too much time, most of you will know that. R for the plain round, D for the deformed, and mesh, which comes in many forms, but we should only be using the ductile mesh. Grades, we've already talked about that. It should always be the E grade, but we've also can talk about whether it should be quenched and tempered steel or microalloy steel. And generally speaking, the recommendation is to use microalloy steel, because with quenched and tempered bars, you get the properties aren't uniform through the bar, whereas with a microalloy it is. So with quenched and tempered bars, if you get some damage to the outside of the bar, then you won't necessarily have the same properties all the rest of the way through it. So you've got to be careful how you handle it. You shouldn't be rebending bars. Lots of old practices on site saw bars being bent backwards and forwards to get out of the way. If you do that, you'll be making it brittle. You're taking it through cycles of load, exactly as I showed you a minute ago, and so you're losing some of the ductility of the bar. So all mesh should now be ductile. And you've got to be careful when people talk about ductility. It's not enough just to have a ductile material. You've got to use it in a configuration which gives ductility to the structure, and that's very important. So in particular, you've got to be careful about laps, that you get the laps right, and there's lots of guidance available on that, which you'll probably be able to see in the information you have. And you've also got to, with mesh, think about that, how that happens on site. Now what I've got here is a suggestion. There are other ways of dealing with this, but one of the things there is it's difficult if you're not careful. You end up with multiple layers of mesh all at one point, with the bars all overlapping the wrong way, and so it gets too thick for the concrete. So what we're recommending there is a layup which sees the bars lapping over each other and cut the corners off at the sheet edges so that you don't get too much of that build-up. Now if you want to, you can see there that, so we get the overlapping bars and then the lapping bars there. It's exactly, once again, as is available in the guidance. If you're short of capacity at that corner because you've cut the corners off and you really are stretching the design down to the last little bit, well, you can add some transverse bars in there to make up the capacity. But you must make sure you've got the laps that you need to, otherwise you won't get the ductility you need to, and you need to make sure you're not building up the thickness of that too much. The quenched and tempered steel I talked about a minute ago, you can use it, but you've got to be careful how you use it. So you mustn't thread it, you mustn't weld it, because that destroys or changes the properties of the outer layer, and you shouldn't rebend it, exactly as I said. And even galvanizing is an issue. You're putting heat into the steel from that, and while there's a bit of debate amongst metallurgists about it, that's the instructions as it stands. Microalloy, on the other hand, because you've got that strength arrived at differently, you can do a lot more with it, but you still mustn't rebend it cold, because you can lose ductility in the bar when you do that. But you can weld it and you can thread it, you can galvanize it, and you can hot rebend it. All this is guidance which is available from the manufacturers. Just a thing about welding, because sometimes it's the get out of jail card that people use. You've got to be careful about it. You should never tack weld reinforcing. You'll create brittle points, and those brittle points will be found out later on, potentially in the earthquake. You should never weld near a bend, because you get the same issues. And you should always weld in accordance with the standard. If in doubt, consult that. There's been a bit of practice advisory out there, so MB or DBH as they were have put information out about that. This is actually about anchoring spirals properly in piles or columns. But you've also, there's a lot of good practice guidance out there about using grade 500 steel. I was going to say, and I think there was about some of the other stuff as well, but that'll tell you about those, the different sorts of steel exactly as we've been through. In the residential space, the guidance you need to know about, these are slightly old actually. This is the guidance on that's been the output of the engineering advisory group on what to do with your residential zones. First about general guidance about repairing, and then the more specific guidance about what to do in TC3. I'm sorry, I can't see my red dot there. And that's all been superseded now by this latest book, which is put out recently. So if you haven't got that and you're working in those spaces, you can download it from MB or you can get them to send you a copy. Make sure you do so. I've already talked very briefly about the things that we have to do in those zones, so I won't necessarily go through this, but this is a bit of the guidance taken out of those where it's telling you, according to the land type that you've got, TC1, 2 and 3, what sorts of things you can expect to have seen and what sorts of things that you should be doing about it. And so typically, down here you'll see in TC2 where the major changes are, there's a lot of discussion about what sorts of foundations you might be using. And so they've got several options on that, which you can see in there, one of which is to put a big, well-compacted gravel raft under there, which does the job of adding a bit of strength and resilience to the ground itself. Alternatively, you can thicken up the slab, they're saying 300 to 400 depending on the type of structure, and basically create a big, strong, reinforced raft under there. And so that will take away the potential for differential movements. You can also look at using something which is a little more like a waffle slab. In fact, you can use a waffle slab, or alternatively, something where you've got just strong beams running through there. And the point of those strong beams is to provide that tie, so you're really preventing that stretch and offset happening that we showed you earlier. And there's the raft, the waffle slab we talked about. Now in the commercial space, we'll just start here with the general observations. So you've already seen this, I won't repeat it, but the critical one obviously being this question about the 95 buildings, again, that we think that those ones have done well. So the answer is, if you're designing buildings according to the current code, good, get hold of the interim guidelines from CSOC, but otherwise it's a step in the right direction. I think at that point I'll invite Des to come up, and he'll add the colour commentary to the commercial building space.